Hello everyone, so welcome to another tutorial of Kubernetes. So we were discussing some advanced topic of pod, how pod works, what are some commands and many different things. So we have also seen how you can create static ones and how actually infect the same architecture Kubernetes is using, because Kubernetes is itself is designed and is using the similar architecture and concept for building Kubernetes infrastructure itself. So we have also seen that how Kubernetes use static pods and how they are not deletable, and there are some security loopholes as well. So due to time, actually the video was getting longer. We decided to do a probe test and a live test or readiness test later on. So these are two important concepts actually. What happen is that whenever you make any service live, well, sure, you get some resources. You really oh, camera is disabled. So great. The thing is that live test means that, for example, what happen if some computer crashes, some program is not working, your computer gets stuck. You are trying to do something, but it doesn't work anymore. Most probably, the thing is that you normally gonna restart the services, or if something is okay after restarting, then it is great. If it still doesn't work, you might be reinstall the software. So this is the very normal process of working with that. But here, if you can see, the similar thing you can do with live test. What does live test means? For example, we have some. So well, first thing first, that how we can do the or check the service. There are only two main method of checking any software is working or not. If this software comes under the umbrella of HTTP, which means that any app or any service which work on HTTP protocol, it most likely be working on the 3080 or some ports. So either you can just check that HTTP port is working or not, or any other software like databases connection or any other connection which is communicating on any port. So normally any single process in the computer, how computer is designed, that any single software in the end after the assembly language, it goes to a single port, and on that port that software is listening, and that's how communication happening. Because in any modern or any classical or legacy software way, every single thing always and every single program of computer in the software engineering really works on either TCP sockets or HTTP or any single sockets or port, let's say like that. If you're confused about what is port, port is nothing but physical address of logical gates or processing power or processing mechanism of any software in the end which processor understands. So there are very simple process to check it. You have designed something, you containerize it. Your container is containerized or wrap around the port, and port are the building block of any Kubernetes cluster. Cluster got a cluster IP or node IP, and that's how overall structure works. Simply. Well, if how you can do the probe test. Let me just show you practical example. First, let me just go to Oracle box, and I start some nodes. These nodes are part of the Kubernetes cluster because it is very important that we have multiple nodes, because normally the cluster works in the multiple node master worker or master slave architecture. We also have seen this in the Jenkins. So we also have seen in the Ansible. In Ansible there was no agent which is working for master. So this communication client and server, master slave, master worker, master node, many software architecture or many kind of different technologies really works on that. So let us take a small pause and until this restarts and everything get ready. Okay, we have right now master node available. Let us just go to the root user. Okay, we are now root, and we are root. The problem in the virtual memory is always that you have to do swap swap of all. You have to do this for each node 1, which is actually something like here. Let's talk the master here and node 2 here, and very quickly sudo swap of a password, and very quickly terminal sudo swap of a, and then we have this thing here, which is very great. Let us just kubectl get nodes. Very cool, we have nodes ready. And kubectl, now it's hanged, kubectl get pods, which means no pod available at all, which is a good thing. Now we create something here, nano, maybe I have created something, lsltr my pod, no. Let's create another stuff, and this stuff would be then nano, and how we can call it? We can call it actually probe live.yaml or YAML also. Here, let me just go to the resources. I don't want to restore it, and GitHub Faisal source. I am at GitHub. My repositories here, labs here, and in the lab we must have Kubernetes here. In the Kubernetes we must have pods, and in the pod we must have something, okay, which means that we need not labs, but we need something else, which is labs Kubernetes, and here is the pod, and here in the pod this is probes, and in the probe this is this. Let me just now copy this, come back to master here, Control Shift V here, good to go. Okay, what's going on here? Very quickly, the API version is v1, which is already we have discussed. Name, any name we can give, app, any app we can give here. In the specs we can add another variable, which is termination grace period second, which is 0, which means that we want to immediately terminate if something happen. With something I mean that if the live test failed. Great, good to know. Then containers, very simple stuff, name of container, image of container, then ports. Of course with the Nginx we always work with port number 80, which is great. it is container port. Here we add another extra tab or another hierarchy, which is live probe, and great. We have two ways, either HTTP GET or we have TCP control. Now, of course, right now we need to write a wrong port like 800. Why? Because if we don't do this, we cannot check that how this really works. And what I do here, I have just written this here, which is really cool and which is very great, which means that I can save it and later on I can also get it with or check it with HTTP GET. So these are two major methods, HTTP GET and TCP socket, both are well. Here I have written the wrong port number so that it immediately gives me error. And what would be happen when I write kubectl apply file path and this name of the file plus .yaml. It's going to create this port, but this port after getting created get failed because we have written this live port. It's gonna test this TCP port, which is 80, and it won't be working, and in the end it is giving us another loop in which it's tried to recreate a port within the setup, and we are trying to mimic or simulate the process when customers are actually getting some problem, and with the fraction of second your whole services or affected services are going to be restarted again, which is very handy and self-healing mechanism. And it is very important concept of Kubernetes because it's a kind of automate in very beautiful way to recreate our resources which are affected automatically until and unless something not very big happen. This is going to help us a lot. Great, this is the concept. I'm gonna save it. Great. Now what I'm going to do, I have this YAML file. I can do kubectl apply file and then probe, and as you can see that another prod name we have written live probe test nginx demo, and now I can see kubectl get pods, and as you can see that maybe I can continuously watch it as well, and the reason of watch 1/1 is ready. And after some time it's going to really check the service. Okay, it's already checked, and here you can see what is happening really is that it's really going to check the service is not responding anymore, and when service is not responding anymore, it's trying to recreate it the second time, the third time, the fourth time, and ultimately until and unless this port is not getting properly ready. So that's basically it. We can also edit it. The best way to edit it is to kubectl edit. Okay, let me show you. So to edit this, we come here to master, and at master what we can do is we can get the name of kubectl get pods here, and our system is working now, which is good thing. Let me just try to copy this resources, kubectl edit pod, and the pod name. Great, we come up with this idea to change this or edit this. Here the port was already 800, which is not right. Now I am not sure how I can WQ, oops, how to save it now. This is the Now this is the thing I have to. Normally it saves in WQ, but how I can save actually this, or how I can even. Okay, this is not even getting. First you need to get into okay, name Nginx, let me QA, ignore this, kubectl edit not pod but pods, because it is single pod, and then maybe I can change really this one here, which means that I'm not able to get into insert mode somehow. What was again name? I'm not. Okay, I was trying to I was really trying to update. Well, I was trying to cube edit, and there are certain limitations on the cube edit. The thing is that, well, with the cube edit is the more convenient way to edit any specification, but the thing is that there are only limited options you can edit, which means that mostly it turns out that you can edit like image and some specification of container, but port is one of them that you cannot edit. So the option we get is let's kubectl get ports. So we have this port here. Let us just copy this port, kubectl delete ports are a single port, it's a single port and then port. Kubectl E is missing, which means that you need to write this. Okay, now this is right now gone, and we have probe live, nano or vim, whatever we prefer. Okay, we come here again and we can delete this x, yes, rewrite this, and then we can say kubectl please apply, and file is probe.yaml. And now, for example, if I watch kubectl get port and name of the port, or okay, get port name is not here, so we can do is that lp dash nginx demo cube. Okay, the problem really is that right now I am not doing anything. As you can see that it has passed more than 56 seconds and your port is working fine. So that's how actually you do probe test, liveness test. is very important, and it's do a lot of good stuff because you can test stuff beforehand if your customer complain. The second thing is probe test. Probe test is nothing but you already know that what error could be happen. You have a little bit idea of the error, for example, because you know that there are, let's say like that, your application is web app and you want to make sure that everything is running beforehand, and you check some critical stuff, like you check the port number 8080 is ready, port number XYZ is ready, and you do some checking, and after that you say, okay, well, great, now I think so that these are the critical step before we go live. And when these readiness checks are passed, then only the process of creating the infrastructure or pod is happening. So this is the difference between the liveness and readiness. We'll do some practical. Well, everything look great. Let's cancel it and now go for readiness pod. Let me just okay, if I go one step back here, I have readiness nginx pod as well. Let me copy this, and we are going to test this similar thing. The only stuff we need to change is, instead of writing live probe, instead of writing the liveness probe, we just do the readiness probe, right? Okay, great. So let us then go to the master, and I could create another file, nano rp readiness probe test.yml, and I could do this, and here is, you can see that we are just testing this time this path. That means that we are just testing in another port. We can perfectly do this as well. In the result there is nothing has been changed, nothing should be changed, and nothing normally changed, because TCP and this both way are just two alternate method of doing same stuff. I hit this, I hit yes, I hit enter, and RP test should be available, and kubectl apply file rptest.yml. It has created something called demo cube watch kubectl get pods. Okay, I get both of the pods here. Okay, if I check it, you can see that this is the RP. This status is now running because we have changed the port number perfectly fine, and this port is has been passed due to this check. But here you can observe something, that this is the readiness is always 0/1, which essentially means that everything is perfectly running, but the status is never ready. Why? Because the port we have written, the probe test we have written, until and unless number of tests doesn't pass, please do not make this container ready. So kubectl delete pod, and I can delete this pod right now, and then later on I can rp yaml and here the port, which is container port, is 80. I can fix it up, and well, I could have create kubectl apply file f and rp rp readiness probe, and the new service should be created. Watch kubectl right now, and then I can live rp dash in rp single dash. My system is not really working at all, which is real sad. Control shift Z V, and kubectl get pods, and this is the pod. And now as you can see that meanwhile we were figuring out how fast it is, and everything is ready and our service is online. So these are two really important concepts which helps a lot. Might be these two small things are seemingly very minimal, or doesn't look that it is a big problem or big thing, but the thing is that when you make sure that live probe, number one, when services does fail, when any critical services does fail, please restart your whole services, recreate it, fresh new copy, and make it running. This is helping a lot. And second thing which is actually to before creating a services, do some check, and if those checks are not ready, some obvious things without which you already know that your service never could be in operation. So why not we check it beforehand? So these are the two tests. Thank you very much for watching. That was that, and might be tomorrow we'll start some deployment topic with some controller ways to create replicas, the set of replicas, creating a daemon, and then later on we can also manage these replicas and do auto scaling. And these are now real important stuff of Kubernetes, which is right now you can see that on which Google is standing right now, on which the Google is working right now, and many big organization. This is now a real crisp, real recipe, which means that deployment of the services at this scale, which does auto healing, auto scaling, and rolling out the updates. And these topics are really important. Although the second topics, which are security and storage, they are also important, but they are kind of at the second priority. But next, these two, three, 4 tutorials are going to be very important. Thank you very much for watching, and if you think that it's helping you understanding some concept, please hit the like button, subscribe, and share. Thank you very much. Bye.